everyone. I'm glad that you're here with me today. We are going to look at transformations of quadratic functions. So looking at the equation and seeing how does it make it change on the graph. Let's begin. Go ahead and So let's look at this one. This is the basic, most simple quadratic function you can have right here, okay? And it is called our parent function quadratic, right? So let's go ahead. This is y equals x squared. We can go ahead and put it in our calculator. Y equals, let me raise that up just a little bit. And I can put in x squared, x right here, and then squared right there. Then I'm just going to hit the table. So second graph to look at my table. And so when I look at this, and I'm going to go up just slightly. I want to include some negative numbers. I have -2 and I have 4, which that makes sense because -2 times -2 is +4, right? That makes sense. And here I've got -1, -1 times -1, +1. 0 times 0, 0. And we have 1. According to this, we have a 1, 2, and then 4. So I'm just do all these. These are all the points, right? I'm going to go ahead and I'm going to plug it in. -2 and 4. So let's see, like right there. And then -1 and 1. And 0, 0. And notice how it's kind of the same on the other side. 1, 1. And 2, 4. This is what we call symmetry, right? Where you can draw a line right down and it's got the same on both sides, right? So it is symmetrical. Now, we're going to go ahead and do our best to make a beautiful line right here. And I'm going to go ahead and sketch this. Ladies and gentlemen, this is what we call the parent quadratic, right? And everything are just slight transitions and movements from the parent, okay? So let's go ahead with this one. Notice that, let's see, a second. Notice that our domain, if we're looking at all of our x values, right? Domains. We're looking at all of our x values and we're going all the way from here. Let's see if that works. That did not work. So we're going all the way from here, where we have an arrow, all the way over here. So basically it's going to continue going on in every direction. And essentially our domain is all real numbers. Okay. And our range, look at that. We're going to start here. Our lowest point is on the y-axis at 0. And everything above, right? Everything above. So our range, and this is from previous lessons, so if this is a little rusty, make sure you go back to that lesson and brush up on that. It's all about y. And it is everything greater than, because it's above, greater than or equal to 0. Okay? All right. So a little flashback from there. Now, let's look at what happens when we have, this equation will be right here, when we have y equals x squared plus 3, right? So right here on each one of these graphs, you'll know that we have the parent quadratic already plotted. And what I'm going to do is I'm going to go to my calculator and I'm going to go to y2. I'm going to type in the same thing, x squared, but this time I'm going to type in plus 3. Okay. And I'm going to go to my graph. And there we are. Here's our first one. And here's our second one. Now it kind of gives me an idea what happened, right? This is what, when it slides, we call it translating up, right? It translates up, but let's find out. Let me write down something real quick. So the transformation that happens here is translating, translates up. And we want to find out by how many? By, and here we could kind of count. We're starting off at the y-intercept. Maybe I can zoom in a little bit. Zoom in 2. Enter. That's too much. So we'll just zoom out. And we'll look really close. 1, 2, and 3. So it's translating up by 3. Up by 3. Make that into a 3. Okay. We can definitely, that's kind of hard to plot points with. So I always like to go to the table. And I'm going to look at that. I got -2, 7. So here I had -2, and originally it was at 4, right? But I'm going to put my new dot at 7. And then I've got -1 and 4. -1 and 4. 0 and 3. So 0 and 3. And then again, 1 and 4. So it's kind of symmetrical, right? That 1 and that 4. And this one's probably going to be right there, right? And so when we look at this, it's like we're taking that same parabola, the shape of this is called a parabola, and we're just sliding it up, right? We're just sliding it up. Everything is shifting up, and we count 1, 2, 3. Translate up by 3. And it's a vertical translation. Vertical just meaning up and down. I'm going to go ahead and draw some little lines, like what that means. So we're going up. Okay? Vertically translate. So the +3 means we translate up by 3. Awesome. What do you think -2 is going to mean? Well, if you said down, I'm thinking you're right? So notice the vertex. We can always count on that vertex, right? If we were translating down by 2, because it's -2, it would be -1, -2. It would be down by 2. Let's check it out and see. Let's go ahead and put it in here. I'm going to just type right over this. And I'm going to put -2. And then I'm going to go to the table. And I'm going to plot my points. I got -2, 2. So -2 and 2. I've got -1 and -1 all the way down. Sure enough, 0 and -2, that's where we had put our little dot, right? And then we have 1, -1. And then we have 2 and 4. Nope, 2 and 2. Hello, because I'm looking at this and I'm looking at that. 2 and 2. I'm just going to draw my new parabola. I'm looking at something like this. Okay. Notice that's the same parabola. It just shifted down, right? And it shifted down by how many? By 2, right? So we're going to say this is a vertical translation. Translate just means to slide. It vertically translates down by 2. All right, guys, that's vertical translation. See you for the next one.